Introduction. Undoubtedly, we have all had them, that moment of extraordinary clarity in which the solution to a difficult problem suddenly seems to just pop in there. Or perhaps it is a punchline to a joke that you all of a sudden get, or the perfect metaphor that suddenly comes into awareness. Where do these whiffs of inspiration come from? Do they just magically pop in there, as if given to us by some muse? Or is there perhaps a more scientific explanation? Insight, or an aha moment as it is commonly referred to, is not mysterious at all. In fact, recent advances in neuroimaging technology have made it seem less mysterious than ever. Insight has been defined as any sudden comprehension, realization, or problem solution that involves a reorganization of the elements of a person's mental representation of a stimulus, situation, or event to yield a non-obvious or non-dominant interpretation. Insights may appear suddenly, but are preceded by incremental unconscious processing. Research by cognitive psychologists and cognitive neuroscientists has shown that moments of insight are merely the result of the brain making connections between weakly and strongly activated bits of information, and then bringing them to consciousness. Insight versus analytical problem solving. Some of the earliest research on insight sought to conclude whether there really was a difference between solving a problem via insight versus solving a problem via a heuristic-driven type of problem-solving methodology. Firstly, there are definitional differences between the two. Insight, commonly referred to as an aha moment, has been defined as a sudden, conscious change in a person's representation of a stimulus, situation, event, or problem. It should be noted that insights, while they do suddenly merge into one stream of consciousness, are preceded by unconscious processing to arrive at the insight. This is in contrast to analytical problem solving, which involves the use of a systematic process or simply logical reasoning to arrive at a solution to a problem. It is deliberate and conscious, and often involves the use of some type of strategy which allow the individual to progress incrementally toward a solution. Because this type of methodology involves storing and manipulating information in the prefrontal cortex utilizing the individual's working memory capacity, individuals can typically fully explain the steps taken to arrive at the solution, whereas with insight, individuals cannot readily reconstruct the procedure followed to reach the solution. Albert Einstein summarized the unconscious nature of insight when he said, "At times I feel certain I am right while not knowing the reason." Differences between the two problem-solving methods vary beyond differences in definition and accuracy of solutions. Neuroimaging studies suggest that patterns of brain activity during and prior to solving by insight versus analysis are fundamentally different as well. This suggests different cognitive strategies are being employed depending upon whether the solution arrives via insight or analytical means. Studies have shown that the brain actually predicts in advance whether the problem will be solved analytically or by insight. For example, Salvi et al. Showed that people blink and move their eyes differently prior to solving by insight versus solving analytically. Other findings using the compound remote associates, CRA, test have provided additional support for the notion that insight processing is qualitatively different from analysis-type problem solving. Compound remote associate problems are similar to items on the remote associates test developed by Mednick in 1962. Subjects must produce a solution word, for example, sweet, that can form compounds with each of three problem words, for example, tooth, potato, and heart. This type of test, while not considered a classic insight test, often give rise to aha moments. They are frequently used when studying creativity, problem solving, and insight. Bowden and Young-Beeman presented compound remote associates test problems to participants followed by a single word that they were instructed to verbalize as quickly as possible. This known as cognitive priming. For unsolved problems, following verbalization participants indicated whether the word was the solution to the problem they had just been given. If it was, subjects had to indicate whether this realization had come to them suddenly, which would indicate insight, or incrementally, which would indicate an analytical solution strategy was employed. Another type of cognitive priming was used to induce abstract thinking in subjects as opposed to concrete thinking by asking subjects to thinking about distant ideas, past or future, remote locations or others' perspectives versus asking subjects to think about ideas related to the here and now. According to control level theory, increasing the psychological distance, that is, thinking about things that are increasingly far away in space or time or about people that are different from oneself tends to engage abstract thinking, which in turn is hypothesized to produce more creative and insightful ideas. Subjects who were primed to think in the abstract by considering ideas at far psychological distances performed better on insight-related tasks, whereas those primed to think concretely by considering ideas at short psychological distances did considerably better on problems requiring analysis. A study by Salvi et al. Suggests additional evidence that there are differences between insight and analysis problem solving, wherein it was revealed that solutions provided by insight were correct more often than solutions garnered by analysis. A possible explanation of this is that insights are typically all or nothing, i.e., there is no intermediate opportunity to alter one's information or solution strategy, ideas, thought processes, etc., when there is a looming deadline, whereas analytical problem solving, due to its conscious nature, allows for individuals to make errors of commission, becoming fixated on irrelevant information, i.e., functional fixedness, etc., as a looming deadline approaches. A pattern of errors made by subjects using either of the two methods suggests differences in cognitive strategies for problem solving via insight and analysis. They found that participants who solve predominantly by insight tend to make errors of omission, i.e., timeouts, rather than errors of commission, whereas participants who tend to solve analytically make errors of commission rather than errors of omission, i.e., incorrect responses.